For any two sets A and B, show that the power set of A intersection B is equal to the power set of A intersection the power set of B. We will prove that these two sets are equal by taking an arbitrary element from the set on the left hand side and showing that it belongs to the set on the right hand side. And by doing so, we would have shown that the left hand side is a subset of the right hand side. Then we will take an arbitrary element from the right hand side and show that it is an element of the set on the left hand side, thereby showing that the right hand side is also a subset of the left hand side. So let's draw an arbitrary element from the set on the left hand side. Let X belong to the power set of A intersection B. Now the power set of any set is the set of all subsets of this set. So if X is an element of the power set of this set, this means that X is a subset of this set, because the elements of the power set are subsets of that set. Now if X is a subset of A intersection B, so A intersection B is the set of elements that are common to both A and B, and if X is a subset of this, maybe it's a small subregion of A intersection B, X must be a subset of A and X must be a subset of B. This means X must be a subset of A and X must be a subset of B as well. Now if X is a subset of A, from the definition of the power set, it follows that X must be an element of the power set of A, because the power set of A has all the subsets of A. And if X is one of those subsets, then X must be an element of that power set. Similarly, X must be an element of the power set of B if it's a subset of. Now since X is an element of both of these sets, X must be an element of the intersection of these two sets. This means X is an element of the set on the right hand side. So the left hand side is a subset of the right hand side, because an arbitrary element X drawn from the left hand side set turned out to be an element of the right hand side as well. Now let's draw an arbitrary element from the set on the right hand side. So let X belong to power set of A intersection the power set of B. If X belongs to the intersection of two sets, then X must belong to both of these two sets, and X belongs to the power set of B. If X belongs to the power set of A, this means X must be a subset of A, because any element of the power set of A is a subset of A. Likewise, X must also be a subset of the set B, because it belongs to the power set of B. You can actually see that we are retracing our steps here. We are starting from here and we are going back up along this path. So in the next step, you can guess that we will say that X is a subset of A intersection B, because it's a subset of both of these sets, so it must be a subset of their intersection as well. And this must be true because any arbitrary element drawn from this set X, note that X is a set because it's a subset of A and it's a subset of B, so it's a set. It can have many elements inside it. Take any element inside X, if it belongs to A and if it belongs to B, it must belong to A intersection B. This applies for any element in X. So the entire set X can be said to be a subset of A intersection. And if it's a subset of A intersection B, then it must belong power set of A intersection B. So this means that the right hand side must be a subset of the left hand side, since an arbitrary element drawn from the right hand side turned out to be an element of the left hand side as well. Combining both these results, we can say that the left hand side and the right hand side are the same set. They're equal sets. So since we retraced the steps that we had set out along on this side of the picture, in the right hand side of the picture, we were basically retracing the steps that we took on the left hand side. So instead of writing this two times, we could have just said that each of these steps is an if and only if step. X is a power set of X belongs to the power set of A intersection B if and only if X is a subset of A intersection B. And this is true if and only if X is a subset of A and X is a subset of B. So each of these steps is basically a two-way implication. It's an if and only if move from any of these steps to any of the succeeding steps. So we didn't need to retrace and rewrite these steps in backwards order. We could have just said that each of these steps is an if and only if step and just written the entire sequence once. So if X belongs to the left hand side if and only if it belongs to the right hand side, it means the left hand side is equal to the right hand side.